Today we're going to look at some problems in Chapter 12, which corresponds to your Week 4 lesson, and these are some problems on statistics. First problems that we're going to look at are on page 696, and we're going to look at problems 1, 13, and 25 together because it's the same data. We want to compute the mean, median, and mode for a set of numbers 7, 4, 3, 2, 8, 5, 1, 3. The symbol for mean is X bar. And in your book you'll see the symbol sigma x divided by n. And that simply means to add together all the numbers and divide by how many there are. So we add all the numbers, and then we're going to divide, in this case, by 8 because there are 8 numbers in our list. Well, you can use your calculator to verify this, but the sum of the numbers on the in this list is 33, and if we divide that by 8, we get 4.125. The mean is just the average, and you've heard of that before. Now, we're going to compute the median next. To get the median, we need to put the list of numbers in order. So we'll sort them from smallest to largest. We have a 1, 2, 2 3s, 4, 5, 7, and 8. So now they're in order. The median is simply the number at the center of our list, or the average of the two that are closest to the center. Since there are 8 numbers, we take the 2 numbers that are closest to the center, and the median, I'll use a capital M to denote that, is 3 plus 4 over 2. It's the average of the 2 numbers nearest the middle. 7 over 2, 3.5. If our list had an odd number of values, it would simply be the 1 in the center. The last measure here is called the mode. The mode is very simply the one that occurs most often. In our list, 3 occurs twice, and that's the only one that occurs more than one time, so our mode is 3. Disadvantage is sometimes there is no mode, other times there may be more than one mode, so it is not unique. Now, one more thing we're going to compute in this section, and that is the standard deviation. Let me get to that page. We're going to go to page 705 and look at problem 19. We're going to compute the standard deviation for the numbers listed in problem 19. Those numbers are 7, 9, 9, and 15. It's a short list, but the technique will be the same no matter how many numbers are in your list. Now the formula, S stands for standard deviation. The formula looks a little complex, but we're going to break it down into steps. It's the square root of the sum of the squared deviations, that is x minus the mean x bar squared, divided by n minus 1, where n is the number of values in our list. So the first thing we're going to do is compute x bar, compute the mean. So we'll do that. And as you recall, that's simply adding the numbers together, and in this case, we'll divide by 4. So the mean, 7 plus 9 plus 9 plus 15 divided by 4. The sum of that list is 40. 40 divided by 4 is 10. So then our average is 10. Now we want to do what are called the deviations. So for each number x, we're going to do x minus the mean. So I'm going to build a little table here. The numbers 7, 9, 9, and 15. There's my list. The deviations, 7 minus 10, 9 minus 10, 9 minus 10, 15 minus 10. Each number minus the mean. 7 minus 10, that's negative 3. 9 minus 10 is negative 1. Negative 1 and 5. Now it's not necessary to do, but I want you to observe if we add these deviations together, we get 0. That's always going to be true for statistical measures. Next step, we're going to square those deviations. So negative 3 squared is 9. Negative 1 squared is 1. 1. And 5 squared is 25. And then we're going to add those together. That's the sigma or sum. We add this list, we're going to get 36. So the first step, we computed the mean. Second step, we compute what are called the deviations. That's the x minus x bar. Then we're going to square the deviations. Then we add them up. So we're breaking this down into several steps. Now there's not too much left. We want to divide by n minus 1. Now in this case, n is 4 because there are 4 numbers. N minus 1 is 3. So 36 divided by 3, that's 12. The last step is to take the square root, and our standard deviation is the square root of 12, which is approximately 3.46. So that's the standard deviation for this set of data.